Welcome to Exploration Radio. I'm your host Ahmad. Data science as a field of study has exploded in recent years. As our ability to collect, store, and interpret large amounts of data increases, it is inevitable that data science will play an increasingly important part in most disciplines. Mining and mineral exploration will be no different. In today's episode, we talk to Richard Scott, a data scientist that works with the exploration team at Oz Minerals, a mining and exploration company based in Adelaide, Australia. Oz Minerals recently ran a crowdsourcing competition called the Explorer Challenge, where they provided access to their proprietary data sets to try to help them identify new targets and perhaps even find new mineral deposits. We covered the basis behind this competition early in episodes 21 and 22. If you missed them, I recommend you check them out. Our intention behind today's episode was simple. We wanted to get the perspective from a data scientist working with exploration mining teams. We often hear the story from the point of view of geologists and engineers talking about data science and what it can do for them. But what does the discussion look like from the perspective of a data scientist? What do they think are the challenges and opportunities of working in mining and exploration? Is it different to what we think? Let's find out with our chat with Richard. We interviewed Richard on the phone from Adelaide. Because of that, the sound quality was a little compromised in places. We apologize for that. Thanks a lot for coming on Exploration Radio.
No problem.
Let's start with a little bit of your background. Prior to joining Oz, what was some of the type of stuff that you were doing?
To a large degree, sports analysis, in particular from a wagering point of view.
So more in the sports side of things. So I'm assuming like sports betting?
Yeah, and like horse racing. So did that in Australia and in the Caribbean, and even before that, I sort of worked for an athletic department at a university in the USA for a while, so like sports-related things. And I was also involved in the late 90s in, if you know, like champion data and the AFL and the beginnings of that sort of football statistics thing. So a little bit of that's my fault. So that's a basic working background there.
So what got you interested in joining the mining industry? How did that come about?
I didn't really pick the mining industry specifically. I was looking to do something different after some other things were winding down a little bit, and just saw an ad and looked at it and thought, okay, maybe, and sort of put it away for a week. Then I showed it to my partner and she said, yeah, you should apply. And I was saying, why would a mining company be interested in me? Like, I don't know much about mining or anything. So she said, apply anyway. So I did. So it's sort of accidental and from that point of view, but it's also science-based. So that, like, you know, having a science background, that something science-related also appeals too. So it was an appeal from that point of view. And I did actually do a year of geology, so not completely unfamiliar with the whole rock thing.
I guess what I'm interested there is that you did a year of geology, but we'll get back to that. So prior to seeing this role from Oz Minerals as a data person, a data scientist, did you foresee mining being an industry where you could have a career in?
Probably not in that sense. I would have thought, unless you're an engineer, and I never really wanted to do engineering. There's too many like lectures and classes really from that point of view. So I never considered myself an engineer from that point of view. And I think I would have probably in my mind it would have been mostly an engineering sort of thing, apart from, you know, obviously the geology guys that are out looking for things. So not really something that like sprang to mind.
So why did you do a year in geology?
Well, I just sort of fit in. A couple of friends were doing it. I mean, it's not like I was science averse because I already done like, you know, physics, math, computer science, etc. So I was doing a science degree and that was just like another subject to fit in. But I've always been interested in paleontology and dinosaurs, even as a little kid.
Of course, that's always the angle people get into geology.
Yeah, one of the lecturers is a preeminent paleontologist. She's found lots of stuff in like Victoria and whatever. So that was a bit of an incentive there. You get to talk to her. So paleontology was an interest at a young age, but not geology in specific like mining sense. I suppose, again, at university, Robert Bakker wrote a book called The Dinosaur Heresies about the origins of the theories of dinosaurs being warm-blooded. And the novel Jurassic Park by Michael Crichton referenced that. And then, of course, there was movies and everything. But so I got like fascinated by that research there as well. So, and read a lot of papers or whatever at the time. So there was a geological sort of interest there.
So once you joined the industry, what were some of your first kind of feelings of how the industry dealt with someone of your profession?
I guess you might say they're probably like in a sense, so like a newer sort of angle for them, although data wrangling and maybe building models out of things. I presume like some companies have been doing it for a reasonable amount longer and have got maybe because they got more resources or more time, but some haven't even started at all. So it's sort of like a newer angle for them.
Do you think as an industry we were a little immature in the way that we dealt with kind of data analysis in some ways?
Yeah, I think so. If you're talking about like a bell curve, maybe a little bit to the left, so somewhere around there, but not bad or anything, but not like bleeding edge either.
Some people are offended by the fact that we say this statement, but in reality, the fact that you were employed in the industry meant that we did have somewhat of a problem that was being solved by hiring you. So I would assume that the fact that companies are hiring more data scientists or more data analysts is really the fact that there is a recognition now that we do have to improve in some way.
Yeah, they've got a graduate intake, I think, on the website now, and data science is one of the possible professions among the expected list of things that you would see. So I would think that would definitely be the case.
Now that you've been in the industry for a while, do you care to comment why the industry wasn't so keen on picking up this skill set and making it a fundamental part of how they worked?
I think my observation of geologists, even back from university, they're perhaps not the most technically or computer-minded types as a whole, and if they're running the data gathering parts of the operation in an exploration sense as opposed to a mining sense, then that could have something to do with it.
That's a fair point.
Yeah, because opposed to say, if you had applied mathematicians or physicists or something, they might have been doing more data wrangling because they had to.
Yeah, so it's more, I guess, the exposure level. The way we teach geology is somewhat analog in a lot of ways. So, you're not surprised that the people that are then interested in that science behave in a more analog way.
Yeah, if you like going and wandering around extinct volcanoes, etc., compared to writing computer programs.
Yeah, that's right. In your experience, are there other industries that you've dealt with that kind of went through the same transition? I guess, you mentioned about sports statistics.
Yeah, they definitely have, because I sort of observed them in the USA, and they were way ahead of Australia in that point of view. So same sort of thing has happened there, whether it's like in football or tennis, and you see big IBM setups at the Australian Open. So they definitely have gone through it, I suppose, a bit earlier, and the sports wagering industry as well.
So how much of this aspect is really, say, the hype around a little bit of data science as well? I guess I get the feeling that the uptake of data science, or even things like artificial intelligence, machine learning, it seems to follow this really hype cycle.
Yeah, you can definitely have a look at the Gartner hype cycle for it, and it'd be fairly up there, not as much as some things.
Yeah, that's right.
When I started doing that sort of thing, I don't think the term existed, or it might have existed in someone's paper or promo material or something, but it's just like statistics. So now, what was a funny quote I saw on Twitter, I think, is what a data scientist is someone that's better at software engineering than a statistician and better at statistics than a software engineer. Sort of like in that space.
So as a practitioner in this industry or in this space, how challenging is it for you to handle the hype cycle when you're dealing with people?
At the moment, it's probably good because they sort of hear those words and they go, oh, yeah, I think I got an idea what that means. That sounds pretty reasonable. You probably know what you're talking about. So it's probably at the moment, it's probably a good thing from a PR point of view. Whether it'll be the same thing in 5 years, good question.
So do you think there's a risk of expectations not working out? Do you have to be careful in that people don't build expectations that you can possibly deliver on?
Yeah, I guess you have to tell them practically you can and cannot get this sort of thing done, or you may not be able to do that at all, or we can do this for you and speed this up. You should be doing this way. So yeah, you've got to manage expectations, I guess, in any sort of project or environment from that point of view. Just, I guess, another business project and stakeholder engagement thing in those terms.
Do you find that a challenging part of your job?
Yeah, I suppose so. I think geologists, this might have been mentioned in a few other shows, might be sort of a little reticent to start with, that computers are going to steal their place and they're not going to have their boots on anymore because there'll be a robot out there. But I think once they work with people that leave them to do what they're doing and try and make their lives easier a bit, and they'll still be doing what they're doing, they'll just have to read more academic research as opposed to doing boring data entry in spreadsheets. I don't think they mind so much at all. If you help them solve this problem, get this into here faster, then they can see the benefit.
I guess I find that really interesting what you're saying. So do you see that as the fundamental part of your job is to actually be a support function right now? I mean, eventually, I think at some point, the way that we do geology will become more digitalized. But right now, do you see your role being a lot more of a support function?
Yeah, it's a support function in the sense that you can't do the science for them and like work out complicated mineral system or something like that unless you happen to be one of them, but you can help them do that. So it's a support role in that sense, where it's a model you build or like someone else builds or one of their consultants or whoever builds may help them or directly find something for them and they'll go, yep, let's go look there. But I think I'd still see it as supportive at the moment anyway, until maybe you get like 5% of geologists that are data scientists themselves in that sense, perhaps. If it evolved enough that they were like practitioners, at the edges or quite a few of them doing that sort of thing, then it'd be sort of like they would probably look for like hybrid people directly and throw a couple of courses those people's ways when they're studying that sort of thing.
So do you have any interest in becoming a geologist? Would you be interested in taking geology courses?
Sure. Like, I've read a few textbooks in that and a lot of papers in the last year. So in that sense, whether it's like of benefit to the rest of a particular team that you're on, that you're sort of out wandering around drill rigs all the time, maybe not, because you could spend your time better doing other things. But I think one of the senior guys said to me recently, it's probably good if you go up there sometime and have a bit of a look around and see how like a joint venture partner runs things, and maybe you can make some suggestions about how they're managing. Because like I got a master's degree in information management, so that is sort of an area of expertise. So that's a good observation on their point, I think. So if you understand the business process a little bit better, it never hurts to talk to people either. So in that sense, yeah, and definitely from an academic sense, it helped to understand it. If you like find like a fun 1950s science fiction movie where you lie a couple of people down and put big metal like helmets on their heads so you can do brain transfer overnight. If I could like get Ian Anderson and Hamish Freeman and do that and dump it all in my head, that'd be fantastic, because listening to those guys talk is like amazing streams of science like come out of them at will. It almost seems just like they're sort of rolling out of their brains, off their tongues, and you could sort of listen to that for like ages and go, how do you guys know all that stuff? So even if you studied it, they got long experience, obviously. So you'd never catch up, I think. But certainly like doing a course here or there, more introductory things. And I have sat in on some workshops they've done, like from a technical point of view. So that's certainly helped.
Okay.
Having enough of a science background to understand chemistry and physics, as opposed to like someone that's like, a finance analyst, then you get a head start from that point of view. If someone says like rubidium to you, you don't generate a blank look and go, what are you talking about? Or like Maxwell's equations or convolution filters or inversion. So what's like a second order partial differential equation, so all that stuff. So it's not new in that sense. It's just that application and what some of the weird mineral names are. I had no idea, but
that's a good point, that your science background obviously helps you in that sense. So I guess to me, it seems like there's two different things happening, where the people that you're dealing with, they probably have to increase the breadth of knowledge that they have to include things like data science. Whereas for you, it's probably the opposite, where you're having to increase the depth of experience you have in, say, geology. So you're getting a little bit more domain expertise. Would that be a good way to put it?
Yeah, definitely. It's possibly an easier transfer that way than trying to make a geologist a computer scientist, mathematician, than to particularly like, someone that's got a solid science background. And perhaps where, they might struggle a bit these days is a lot of the courses have had some of the like science and mathematics and whatever taken out of them. So it might be harder to find people with the science backgrounds to support at that base level to start with, because you get a whole bunch of programmers who've done some sort of computing degree, but they won't have like any science in it or maths in it at all, really.
I guess the point I was trying to make there is really that people think that geologists should pick up these skills, but in reality, knowing what you should pick up is quite important as well, because otherwise, the range of stuff you'd have to learn is just so wide.
Yeah, it's not possible to like learn everything to a professional level, but I think it's certainly like helped them, because they got to work with geophysics consultants or geochemists or whatever, so that they understand what they're doing, so they can keep an eye on it. Say, like, does it pass the sniff test? That looks silly. Then so they've got to understand enough of the basics. I think even like data scientists, what are these guys trying to do for us? So like got to be able to explain it to them and they get the basic idea. And some of the guys, they did have a course run like along those lines. So they are certainly interested, in the basics or that sort of thing, I think, because ultimately they're like inquisitive scientists, really.
Mm-hmm. In your role, do you deal with mining production teams as well as exploration teams?
Only occasionally. I sort of like help out the guys in like another team a little bit, and they work more in that sort of area. So, but not directly. And I think because of my background, I'm probably drawn to the exploration side more than the mining side.
Why is that?
You're sort of looking at prediction, I suppose, as opposed to optimization to some degree. If you had to like give it a broad sort of like a mathematical class in that sense.
Yeah, I guess that's a good way to put it. The problem in exploration really is a probability-based prediction, whereas
That's right.
in mining, you're really trying to optimize the thing as best as you can.
Yeah.
And the rate of feedback you have is completely different as well. In mining, you get a lot more feedback, so you can optimize on a timely scale.
Yeah.
Whereas in exploration, you don't get that.
There are lots more numbers on like a belt or how much they've dug out or what percentage their grades are compared to how many IOCGs are there in South Australia, like much bigger numbers at one end than at the other.
So as a company then, as a mining company, if you're going to apply data science as part of your business, you then have to have essentially two different skill sets of data science in your company. Would that be a fair way to say it?
I think it would probably be beneficial if you had people with a bit of background or experience or knowledge in like domain knowledge in the area. So if you had someone that was a bit of an engineer that became a data scientist, or like a miner, or someone that had been like actually drilling or was just a mine manager and they got into that area, like I think all little bits like that would certainly help. But yeah, it's probably a bit of a different approach or what the particular person's interested in working on. Probably get you like slightly better results.
So in saying that, do you think companies have to structurally change the way they handle data or the way they create teams in some way to be able to do this?
They have to give it consideration so that it's like accessible, storable, transferable, and have the ability to be manipulated more easily, I think. And that, I guess, goes for the people they get information from as well as, internally. Like government surveys, etc., might be struggling or working at that sort of thing at the moment. How do you make it more accessible? So the better that process is, I think the better results for like everybody. Then we get cheaper computers in the end because the cost of everything goes down for everyone. So that's good.
I guess my assumption is that companies aren't very sophisticated in kind of handling the data because, we don't really have highly sophisticated end users of that data. But if we start putting more sophisticated end users of data, then how we handle the data and how we manage it and store it and allow it to be accessed will have to change as well. So what are some obvious kind of low-hanging fruits in that space?
Well, I may or may not have heard this week that someone like working on the ground with a joint venture may have had to write the same stuff into a report 3 times. So that's a really obvious one. Like a programming mantra is write once, use everywhere or many times. So things like that, or like automating stuff you can throw into a database. So you can do thousands at once and like go off and have coffee, as opposed to having some like poor person sit there and do it for like 2 weeks solid, bored to tears, or like a geology student marking things on bits of broken rock in core trace for 3 months. When a camera can do all that, and then like say a data scientist can train model probably in a fair bit less than 3 months to like do probably a better job.
Yeah, that's fine.
And then a geologist can use their actual brain and like science skills to do something more useful for the business in that sense. Maybe some simple things like geologists shouldn't be wrangling spreadsheets, it's a waste of their skill set.
Oh, yeah, I completely agree. But I mean, in saying that, do you think one of the limitations for why we've had a vocational student doing a lot of this stuff is because up until now, the cost for doing it was probably too prohibitive for companies to take on?
Yeah, I think so. With the cloud storage providers and costs for things like S3 being, really low, then if you've got 100,000 photos that take up many terabytes, then you can do something with them without costing more than employing a geology student
I guess the industry does get, I think, chastised a little bit that it doesn't make this investment. But the flip side of that is that when you're talking about large assets like mines, building an IT infrastructure would have been quite cost prohibitive in that sense to do it. So until that price point comes to a point where the industry can take on that financial risk of doing it,
Yeah.
and not just the financial, but also the workflow risk that, you're going to fundamentally change how you work, and you don't want the mine to grind to a halt because for whatever reason. My feeling is that perception is a little bit unfair because the industry, I think, has done it in the time that it suited it to do it, really.
Yeah, probably mostly, I would think, depending on where you are. I suppose maybe if you're like drilling somewhere that's nice and close to a big city or whatever, and if that was someone's major business focus, they might have been able to do it a bit earlier than someone whose properties are way out in the middle of the desert. Satellite phone doesn't even work very well. So if it's mainly like dispersed out away from people, certainly like, data transfer, definitely an issue. And if you've got to do it by like sneaker net or Toyota net or whatever, then...
Yeah, that's a challenge. I guess I want to go back to one of the things that we were talking about before. We were talking about what role expertise plays in this setup. I find that there's two kind of camps of people right now. One that seem to think that automation will do everything and you're just going to get rid of geologists, not just geologists, but fundamentally get rid of people in some ways. And then there's the other camp, which seems to say that automation will come in and will replace certain things, but it won't just be a wholesale change to full automation. You'll still need people, largely because people will provide some level of intuition or some level of built-up expertise that they'll have. And I guess making it a little bit more specific to the competition that you guys are running, which is around exploration. I guess I look at exploration as a task that has high degrees of uncertainty attached to it that has to be handled in some way. And in saying that, do you feel is the whole exploration methodology highly amenable to a full automation, or do you think there is a role for people in there having intuition or providing domain expertise along the way?
I don't think exploration can be fully automated. Pretty large chunks of mines can be, but don't think exploration can, because if someone's going to come up with a new style of deposit, they have to think about it to do it. And we definitely don't have any computers that can do that. Doing some sort of unsupervised learning thing may point you toward something like that, but then it's an aid to the brain power of the geologist. So you're probably always going to need them just literally to do the thinking. Not even quantum computers, which don't really exist in a usable sense, are going to be able to do that sort of thing. They're just going to be able to do more of what computers are good at more quickly. And geologists are sort of like an oddball blend of like chemistry and physics and other bits and pieces. So synthesizing that intuition from like across multiple domain like that, it'd be pretty tricky. And I can't imagine anybody running a computer that can do that anytime in our lifetimes anyway.
So is this part of the discussions you guys have in Oz, where you acknowledge the fact that it's going to have to be this machine that you have to build through by having different people provide input in the process rather than just looking for like a panacea approach to automation?
Yeah, absolutely. Like I've generally always said that we can build models, etc., but it needs the domain input to categorize it. And well, that's fairly standard, I guess, for like inversions too. If you don't constrain it in some way, you've got an infinite number of differential equation solutions that, that's not any use to anyone. So you have to have a geologist to do that too. And with more of the finds going to have to be undercover, there's going to be have to be more of that work done as well. And I think we've even had, the conversation with geologists that are worried about being replaced, saying, no, it's not going to happen.
I mean, I guess, it's refreshing to hear the view, because I think philosophically, if you thought about how exploration works, I mean, mining, I think, is a completely different thing. There is a certain degree of repetition in the data as well as the process, which you can definitely optimize, and a machine will probably do it a lot more than a human being can. And arguably, a lot of the errors we have in the mining process are largely because of human input rather than, some fundamental workflow problem. But I think in exploration, I don't philosophically see how you're going to solve that problem from just pure automation or from a machine point of view. And I think you made the point, which is a very valid one, is that how could you ever cover all the outcomes in exploration through a programming point of view?
Extremely difficult. Even like talking about the sports thing, predicting who's going to win something is hard. And you can have various models that say this, but there's usually from, the people that are experts at it, there's some human input into that as well. So anything that involves in prediction that's got some sort of random or other unknowable elements in is a human problem to deal with, really.
I guess the leading point to this discussion was that right now we, I think, put too much effort in trying to make the data analysis side better. But there's also another point is that you're probably going to have to invest in people as well to make them better along the process as well. I guess that part gets a little bit ignored, I feel, right now in this discussion.
I think education's always important. I suppose if you've been in IT for any length of time, you've got to keep learning stuff to keep up, because what you might be working on now you didn't exist 3 years ago. And science is probably similar in some degrees. There's always new research coming out, or someone's got a new paper or idea about something. So you've got to keep up there. So you have to have enough people that are able to do that and keep going without burning out.
Yeah, that's a good point.
The constant learning pressure. Some people don't like that at all. They just want to go and do their thing and then be done.
Yeah, that's right. And I think IT is a great example. The reality is that most professions are probably going to have the skills replenished a lot quicker than they probably did beforehand. And I think geology probably hasn't had that till now, but it will definitely go through the same process as well.
Communication of knowledge worldwide is obviously much quicker now. So I guess ideas and information and research can spread more easily than having to wait for the one copy of a journal to arrive on a boat in 3 months and then be stashed in the one city that you've got's library. And then you have to catch a horse and cart to go and read it.
I guess I'm interested to know your view. 25 years from now, you're still working in this industry. How do you see that world compared to now?
Yeah, well, one thing I guess geology doesn't seem to have is error bars. Black hole image discovery, they had, 6.5 plus or minus 0.7 megasuns was the mass of their giant black hole at the center of a galaxy. But you don't very often see that in someone's geological map or whatever. How accurate do they think that is, or how accurate is that particular inversion, or how likely is it that it's right-ish? So I would hope to see a lot more quantification along those lines, and presumably, so you would get a huge range in the particular space that they've constrained, with numbers alongside saying this one's 32% likely and this batch in here is 69 to 74% likely, so that there'd be a slightly more quantifiable or rigorous approach to things, and that the data from various domains could sort of be auto-magically brought together more easily, so that you might get dashboards of models spat out, even if it's holographically in 25 years, or in a Google Glass sort of a wearable sense. So
yeah, that's
maybe you can be sitting in a coffee shop not looking like you've got any technology at all, and still doing this sort of thing, as opposed to having to have a phone or a laptop or whatever with you. But I would hope the data would be turned into knowledge more quickly and more easily, enabling the exploration and finding of resources probability to be raised. I know, do you think you can get from 1% to 2% or success in 25 years?
Yeah, well, that'll be the holy grail.
Yeah. So something along those lines. I think 25 years would be hard to predict what might happen, but you would hope that that's what would be going on, and scientists can spend more time on science, which is necessary for humanity to progress in that sense, as opposed to doing boring things that someone else can do for them so they can think.
You made a really interesting point there, which is around the rigor of how we go about not just doing our analysis, but also communicating it. And I think, one of the reasons I think is because we spend so much time doing other shit that, the stuff that we really should be doing ends up taking 10% of our time at the end.
That's right. Writing the abstracts and the error calculations or whatever, you skip that and just here's the map and a few notes.
Yeah, exactly. We always end our interview with 2 questions for people. So the first one is, what is something that you think needs to die in mining? It could be an idea, a concept, a behavior, anything.
Can I have 2 things?
Yeah, go for it.
Okay, first one is labs that send people their information and data in PDFs. Please don't do that. If you've been doing it for 20 years, you'll be able to send it to your clients, in whatever format they would like, and would be actually usable, because it's the one thing you do in that sense. That's one.
That is spoken like a true data person.
Yeah.
The biggest bugbear currently is the fact that you get sent data in a PDF. That's excellent.
So that's one. And another one I would say would be the over-reliance on expensive proprietary software that's not interoperable because, expensive proprietary stuff, you could get some more of the software or hire more people, sort of like a type costs. So if that goes away, then I'd be pretty happy with that. And there's a 3D visualization group at UWA. So if anyone wants to do a PhD and whip some of that up for us, that'd be fantastic.
I think it's a really important point that, one of the reasons we don't have a lot of, I think, input from other disciplines in mining or mineral exploration is because we haven't democratized the data or the skills really across a wider band. 3D modeling, I think, is a classic example where very few people are able to do it, and hence the input that we're getting is very limited as well.
Yeah, so that I've heard people say a lot, geology is a 3D problem. So if you haven't got good 3D tools that are accessible to lots of people, then progress is going to be slower and the results will be worse, generally speaking.
Yeah, exactly. I mean, that's not a surprise by any means.
No.
So the last question, conversely, what is something that you think we should keep in mining or exploration at all costs? Something that we should never forget?
That the people like doing the science have got time to think, like they've actually got time to sit there and think about a mineral system or whatever they need to, like, in a hardcore academic sense. Can they think up something new about this? Can they work out what's going on? They need that sort of time to work there for things to get better or get found more, I think. So that definitely needs to stay. So you can't spend too much of their time on management or data wrangling or HR forms or whatever. Because like it's a problem in, computer programming or whatever, context switching. So if you have to suddenly go and do another thing and another thing and another thing, it takes you out of that deep head space that you might have had an insight into particular mineral formation. Or the same if you're 5 levels deep in a computer algorithm, it can take you half an hour to get back into it if you get interrupted. So I think science time is a critical thing.
Richard, you're going to be a messiah for most geologists in the industry with comments like that. So I think that's a perfect point to end on.
Thank you.
Exploration Radio is brought to you by Steve and Ahmad. This episode was produced by Ahmad, edited by Andy Marr, and recorded at Vision Studios in Perth. If you want to find out more about this podcast, check us out on explorationradio.com or follow us on LinkedIn, Facebook, or Twitter. And we're even on Instagram. And if you like this podcast and want to help out, well, there's 2 things you can do for us. Give us a review on iTunes, Stitcher Radio, or wherever you get your podcasts from. And consider supporting us in producing more of this content. You can find the details on how to do that on our website at explorationradio.com/support. Until next time, let's keep exploring.